Good afternoon, everybody. Thank you for joining us for today's webinar. If you can just give me a minute or so for the remaining people that are starting to join to finish the process, that would be good. Shouldn't be too long, and then we'll get going. But thank you again for joining us. And yeah, in a minute or so, I'll start. Thank you. Okay, so the remaining people have joined. So well, thank you once again for joining us. This week, we just wanted to really go over sort of summary of where Xyzal is at with their Wi-Fi 6 products and their multi-gig switches, because over the year, the Wi-Fi 6 access points came out. They also needed the high-end Wi-Fi 6 devices, also needed the multi-gig switches. They came out. So now there's a reasonable product set that's now available. So that from a solution set point of view, it's all there. So we just thought the best thing to do is just to give a quick recap on our access points from the Wi-Fi 6 point of view, and just mention the multi-gig switches that go with the top-end access points as required. Okay, so we get going. So one of the things, obviously, we just wanted to point out that this is a bit of a marketing slide that we were given. Obviously, now Wi-Fi connectivity is really a given from a business and a home point of view. I mean, it has been, and it still is hugely successful, probably way beyond probably what the original people thought all those years ago. So there's some Gartner figures that show that basically the number of businesses that will be connected to the internet is just going to be in the multiple billions, and then hence the number of devices connected is going to be even higher. These are figures that we were given by Gartner. And then the other day, I was reading something about COVID and India, and one of the things India is going to do is it's going to be running fiber optic networks to every major village within India. I think it's something like 1,000 villages in 1,000 days was the actual headline political figure. And they're doing it for health reasons as well as developmental reasons. So if you think of the country the size of India, all that fiber connectivity and essentially with wireless connectivity at the end of it is just going to continue to grow in an explosive fashion. And obviously nowadays we just expect Wi-Fi, as obviously well as mobile connectivity, to literally be everywhere. There's nowhere really that you would expect to go and not have Wi-Fi connectivity. I think you'd be hard pressed unless you can maybe go in a basement of a multi-story car park or something. So really the Wi-Fi 6 revision, which is now well stable, virtually fully approved. It's proper IEEE. Technical name is 802.11ax. It's aiming for high efficiency, improvements in throughput, consistent quality connections, and obviously fast connections, but also variability so that you can have a mixture of low and high-speed clients, so on and so forth. So some of its key figures are, and these are, clearly perfect world scenario sort of throughputs, like up to 10 gig throughput, much higher capacity with from 4x4 MIMO up to 8x8 if you've got the processing capacity to do it. It will continue to be backwards compatible, still continue to support dual band, so 2.4 gigahertz and 5 gigahertz. Some people might have also seen in America there's some frequency that's being freed up in the sort of citizens band space. So I think they might call it Wi-Fi 6E. But if that frequency is freed up over here, then there'll be additional there'll be an additional band as well, which will increase throughput. There's some of the technologies that have been introduced as a result of Wi-Fi 6 is basically come about from some of the mobile phone technology that's been used and re-implemented within Wi-Fi. So basically we've got things like 8x8 MU MIMO. That basically, that's in both the downlink and the uplink. So whereas with 802.11ac wave 2, that was only on the downlink side of it. So basically with Wi-Fi 6, it's in both directions. And so that allows you to serve up to 8 users simultaneously for a substantial performance boost. We've also got new coding schemes, which is basically the orthogonal frequency division, multiple access. So I'm not a mathematician, but essentially with very sophisticated DSP and these algorithms, you can get much more finer grained and efficient usage of the wireless space, or the Wi-Fi space. So basically, the 4G has got this LTE proven OFDMA technology, which basically allows for much more efficient access, and it basically allows multiple users with varying bandwidth requirements to be simultaneously served from the transmit and the receive side of things. But it's also one of the advantages of it is where it's not just efficiency and density of coverage, but it also helps you with a much more finer grained unit of scheduling, which is the other feature that's coming up, which is a thing called resource unit scheduling. There's some pictures that are coming up which might help with that as well. So basically, the previous AX spec used smaller resource units for transmission, which increases the efficiency over the previous standard, as it allows the resource units to be scheduled and allocated by the access point. And it gives a much more fine-grained control over the bandwidth and how it's allocated and used by the client. One of the other, as I said, there's a drawing coming up which will greatly help the resource unit understanding. As in previous specs, with increases in semiconductor technology, what you find is that the ability to increase the modulation scheme, so whereas before it was 256 quadrature amplitude modulated, it now can go up to 1024. So those symbols within that diagram represent bits, more and more bits. So it basically, when you get to 1024 cam, it means that it gains up, roughly speaking, about a 40% increase in headline speeds using the same channel space as you do in 802.11ax. There's another strangely termed new characteristic called the BSS color, so the BSS frame coloring. So basically, I'm just going to read this bit out because I'm still getting my head around it as well, this bit. So basically, the color coding is a method for identifying overlapping basic service sets, the so-called OBSSs. Each access point is able to detect the BSS color identifier, obviously, that's actually a numerical number within the protocol and within the frame, to determine if it belongs to the same BSS or if it can ignore it and transmit on the same channel. This is based on the thresholds, and that takes into account the receive side signal, basically the power levels. The idea here is to try and address some of the challenges of co-channel interference. So whereas any weaknesses in the past are now being continually addressed, and they're trying to improve on it and come up with technology and digital signal processing schemes to actually address some of the previous weaknesses. The final sort of improvement is this thing called the target wake-up time, and this is another important resource, a scheduling feature basically, which is actually supported by 802.11ax. It essentially allows devices to negotiate when and how often they'll wake up to send or receive. So TWT, as it's called, increases device sleep time and in turn substantially improves battery life. Now this is ideal for Internet of Things type devices, obviously mobile phones that are in a sort of a semi-suspended standby state. So a lot of the things and features and improvements that you'd like to see are coming about, and they're rolling them up into the new spec. As ever, there's backwards compatibility as well. So this is just showing you some of the original specs, and obviously this time they've basically put numbers to it, the so-called 4, 5, and 6, whereas before you used to know them as the 802.11n, AC Wave 2, and now AX. But the Wi-Fi organization has come up with 4, 5, and 6. So if you look at the maximum theoretical speeds for each standard, and you look at the connectivity under 2x2 and an 80 megahertz channel, or 4x4 and an 80 megahertz channel, you can see the differences and the improvements in throughputs, and how over time it goes up and up and up. Obviously now, when we're with AX spec, you can see that we've basically bussed the 1 gigabit wired connection speed. So that will be that explains why there's multi-gig ports coming out on the Wi-Fi 6 access points as well. But you can see all of the improvements end up having not so much some unintended consequences, but for the really high-end Wi-Fi 6 implementations, you are going to need multi-gigabit switches as well, which I'm going to mention as well. So when you look at the technical improvements that have happened, obviously you get sent all these slides after the presentation, and I'm not going to go over these in great detail, but you can see how each time the specification is revised, how bands go up, channel bandwidth and the usage of those bandwidth goes up. Coding schemes, i.e. the symbols within the OFDM modulation schemes, everything is increasing. And the ultimate benefit of that is the client-side throughput, which just relentlessly increases, obviously, and the number of connected devices that you can support increases as well. One of the difficulties with some of these specifications is trying to come up with a drawing that explains the differences of the specification. So this is a drawing that's hopefully trying to help with the differences between OFDM, I'll get you in the other next slide, and OFDMA, so multiple access. So it's trying to show that on the current schemes, you have a user transmits across the entire channel width. So that whole channel width is used up by that particular client for that particular transmit period. And obviously, if they don't need that much bandwidth, it's all wasted. Whereas now, with multiple access, you can divvy up the bandwidth to much finer grained resource units. And then, as you can see, so if your user user one, which is red, which needs that amount of bandwidth, then they can have all of those resource units. Whereas if you're green or yellow or blue, and all of a sudden you did need more, you can have more. But if you don't, then you can just have what you need. So it's a much more efficient usage of the airtime bandwidth. Once again, a great improvement. This is another useful drawing that our product marketing people try to come up with. Obviously, the shuttle, it's got a 20 megahertz channel and it has all that bandwidth. But if you've got another huge number of smaller bandwidth devices that need that connectivity, this is a way of just giving you a diagram as if you break it up into much finer chunks with much finer channels, for want of a better word, you can cope with far more people. Now in many respects, at long last, we just get on to what our current access points are in relation to AX. So the devices that are currently available, and I've got the UK parts list at the end, is the NWA 110AX. These are devices that you can order and you can buy now. The WAX 510D and the WAX 650S. So we go from the original one. So the NWA 110AX, that's a Nebula Flex device. It still has a 1 gigabit wired connection and it's Nebula Flex. So it can be managed by Nebula or you can use it standalone. It's a 2x2 device on both bands. Then we move up to the WAX 510D. That is a 2x2 device as well. It's Nebula Flex Pro, so it comes with professional licensing if required. But more importantly, it comes with the dual optimized antenna. So you can basically mount this device horizontally or vertically, set the switch for that mode of working. Pardon me, either a hard switch or a soft switch within Nebula, and that will work in the appropriate dimension. The top end device at the moment is the WAX 650S. Now the S is for the smart antenna. It also has Bluetooth built in, an extra scanning radio as well for looking for interference and so on and so forth. So this is a 4x4 device on both bands. And as you can see, the throughput requirements of this go up substantially to the extent that you need a 5 gigabit multi-gig port, as well as, if you wish to use it, there's also a standard 1 gigabit port as well. This is also a Nebula Flex Pro device. So the devices from the left to right, the first, the third, and the fifth device, they are currently available. To the end of this quarter and the next quarter, you will also see the NWA 210AX and the WAX 610D come out. They, as you can see there, at the 5 gig, so the NWA 210AX on the 5 gig band, that will be available with 4x4. And that will require a 2.5 gig multi-gig port because basically the throughput's going to go up substantially with 4x4. Then on the WAX 610D, what you've got on there is, once again, you've got 4x4 on the 5 gigahertz band and the dual optimized antenna on that. So that's the whole suite at the moment. As I said, the first, the third, and the fifth devices, they are currently available, orderable, and you can get them from distribution and have been for a good few months now. So the devices with the multi-gig port requirements, so basically 2.5 gig or 5 gig, mean that you're going to require a multi-gig port switch. And this is what I'm going to go over next, because they are now available, as you can see, they tend to be classed as M gig. And also they are, for the top end, I'll just go back one slide. Sorry about that. So the 650S, because of its speed and the number of antennas and all of its features, it requires a much higher PoE draw. It needs so-called BT spec PoE, which is essentially the PoE++ spec. And this is what these multi-gig switches provide. So you can see what the spec numbers are there, BZ and AN. They allow massive improvements in network speeds. This is all over copper, not over fiber, but copper. So you can see on this table, if you've got Cat5e wiring and you've got you want 1 gig, 2.5 and 5 gig ports, you can see whether it supports up to 10 gig or not, and what the PoE spec that it supports or not is on the table. So you can see that even with Cat5e, you can get up to 5 gig and PoE++ without any trouble. Obviously with 10 gig, you can't use Cat5e, but with 10 gig, with Cat6 or Cat6a cabling, you can even support up to 10 gig. Cat6 obviously is up to 55 meg, and obviously Cat6a will allow you to drive 10 gig to 100 meters. But you can see that a lot of cabling already within building can take advantage of these multi-gig ports. So what we're going to do is swap your switches out, swap the access points out, and off you go. This is just a simple picture of the new XS 1930 series switches. So these are multi-gig switches. They are Nebula Flex, so they can be managed standalone or they can be managed via Nebula. So there are two models. There's the Dash 10, which is a non-PoE device. So it's got 8 ports and it's got 2 SFP plus ports. So the 8 ports are all multi-gig. So that means they can be 100 meg, 1 gig, 2.5 gig, 5 gig or 10 gig. So on all the copper ports, you can go up to 10 gig. And obviously on the SFP plus ports, you've got 2 10 gig trunk ports. The PoE device is the XS 1930 12 HP. Now that's got 8 PoE ports. And the fantastic thing about this particular PoE switch, it's got the full 375 watt PoE power available to that single switch just for 8 ports. So basically you can support up to 60 watts per port. So it can power PoE++, so-called BT spec devices. So it powers the WAX 650S smart access point. But obviously you can use these things for maybe point zoom cameras that are outside that have got heaters in them and things like that, or access control, or small computers that have a 50 to 60 watt power draw. So it's not just high-end access points that you can use these switches on. You can use them on anything that requires either higher speeds and or much higher PoE budgets. Some of the other key features, it's got like a restore button, so it can restore to the previous configuration whilst you're on site easily. It's got intelligent cooling, so if it is in the office, it can be ultra quiet. It also has multicolor LEDs, so that basically you can identify the port speed easily if you're physically on site and you're trying to debug things. You can do all of that, and it also has PoE consumption indicators and so on and so forth. So really nice switch. As I said, Nebula capable. Excuse me. Same quality background from Xyzal switches. So use this switch with the appropriate access points, and you've got a complete, very, very high-end Wi-Fi 6 and wired connection solution. The other thing we wanted to do is obviously just to show people the competition for the XS 1930 series switches. So you can have a look at the equivalent type of switches, and you can see the advantages that the Xyzal switch offers. In nearly all aspects, it's a fantastic switch, above and beyond the competition. So you'll get these slides. So if you want to have a look at specific points, if you've got quotes or tenders to work on, you'll get these slides afterwards. And again, it's an extension of the matrix and all the different features. What I wanted to do as well is obviously give you the UK part numbers. So basically, You've got the NWA 110AX, and there's two particular part numbers at the moment. They are the same device, but the only difference is pack quantity. So you've got a single pack or a triple pack. The WAX 510D, so that's the AX device, sort of mid-ground device, but it has the dual optimized antenna. You've got a part number there which excludes power supply, power adapter rather, apologies, and that's a single pack, or there's a 5-pack quantity as well. Obviously, the WAX 510D is a Nebula Flex Pro device, so it does come with 1 year of Nebula professional licensing as well. The 650S device, that's the high-end, that's probably our highest end smart device. Sorry, smart antenna device. That's also Nebula Flex Pro, so it comes with 1 year of professional licensing. Then you've got the multi-gig switches below that. So obviously the XS 1930-10, that's the non-PoE device. And then the -12 HP, that's the 12-port PoE device. And then I've just put, obviously, for the trunks, sorry, the Ethernet accessories are simply the SFP plus 10 gig transceivers, fiber transceivers. So if anyone's got any questions, I was going to just wait around for a little while if anybody's got any questions or want me to go over anything in more detail. So, as I said, the idea really was just to give a revision of the two product ranges. So there's Wi-Fi 6 and the multi-gig switches, bring them together, and you've got a complete solution. Whereas before, the switches, the access points had come out in advance of the switches, and now everything is rolled out, and so you can create a complete solution. So if anybody has got any questions, I will hang around to answer them. But thank you very much for your time, everybody. Hope you're all well and business is getting back to something like normality, as much as normality can be these days. But so thank you very much for your time. You'll get sent the slides afterwards. Any questions, then give me a shout. Thank you very much.